Hi. So this is our second dip into word problems. I'm going to start with the same review, and then we're going to look at harder problems than we've done so far. As a reminder, what is the question looking for? If there's things you can translate to math, use them. When you're doing harder ones, you might want to write an equation. It depends. Sometimes it's easier in your brain to not. It just depends on what works for you. And then it's nice too to check your solution at the end. Really quick, here are some of those important words that you're looking for when you're going through these. Some words for adding and subtracting, some for multiplying and dividing. Oh, don't forget also you'll see the words per and each for both dividing and multiplying, which is quite annoying. And consecutive numbers, you start with a number x and you go up one each time. If you have consecutive odds or consecutive evens, again, you start with some number, but then since you need to skip, you're going up by 2 each time. And this could keep going if you had 4 that you needed or 5. All right, we're just going to dive in. The quotient of 6 less than a number and 5. We don't have anything to solve here. We just want to write this in mathematical terminology. So the quotient is telling us there's going to be a division problem of 6 less than a number. A number, we should probably put X or Y or whatever we wanted. And 5. The quotient of 6 less than a number and 5. When you see quotient or product or even sometimes sum and difference, see quotient of something and something, those are the two things that are going to go into your division problem, right? It's like this divided by this. So for our purposes here, we know that we have the quotient of 6 less than a number and 5. So 5 is on the bottom. And then we had 6 less than a number. If you remember that 6 less than means we're subtracting 6, but we need to subtract it from x. So it needs to come after. It's a bit confusing. So 6 less than a number is x minus 6. So we are really just writing 6 less than a number divided by 5. So we took several phrases that we could translate. 6 less than. And we also took quotient of something and something. And we had to kind of combine these together to decode this problem. We're going to see more of that as we go on. All right, now we have one we have to actually solve. Carla bought movie tickets on half price day for $18. How much would they have been on a regular day? So half price of the regular day is $18. You probably know all the way, like right now in your head, how much it is. But in case you don't, if half of something is 18, what's the whole thing? We could divide both sides by 1/2, or to cancel out 1/2, we can just multiply by 2, because 2 and 1/2 cancel to be just 1. So regular price is going to be 18 times 2. It's going to be $36 on the regular price date. Maybe you used X for that, or maybe you didn't even have to write out an equation and you just knew this one in your head. The difference, subtraction, of a number and 6 is 13. A number. So we're doing subtraction. The difference of a number and 6. Here's my number difference is 13. What's the number? We're going to go back in time through this problem, right? Before I subtracted 6, what did I have? I had 19. a math class has only business majors and nursing majors in it. We're not worrying about anyone else. The number of business majors is 3 more than twice the number of nursing majors. If there are 11 business majors, how many nursing majors are there? So nursing majors is what we're looking for. We know we have 11 business majors, and we know that business majors is 3 more. Ooh, we're adding 3. That's okay. We can do it that way. Then twice the number of nursing majors, which here I've been using N for. So we know that it's 11, and we know it's 3 more than twice N. So since those are both equal to B, I can just write this as an equation. 11 is equal to 3 more than twice N. So we're just going to solve this bad boy just like we might any old equation. Twice the number of nursing majors is 8. So I can divide by 2 and say that my nursing majors is 4. There's only 15 people in this math class. Too bad. Double checking. Is it true that 3 more than twice 4 would make 11? Twice 4 is 8, plus 3 is 11. Yes. Phew. All right. Guillermo bought plywood and tarps at the hardware store. Plywood, tarps. The number of plywood sheets was 5 more. I put it at the end of this time. You don't have to. Then 3 times the number of tarps. Why did I put a box? I could have just put a T. Anyway. And we know he bought 14 sheets of plywood. And the thing we're looking for is tarps. So 3 times tarps plus 5 is giving us those 14 sheets of plywood. Going back in time, take away those 5. And now we have 3 times the number of tarps is 9. We're going to divide by 3 to get rid of that, multiply by 3. And our number of tarps is 3. So Guillermo in this one bought 3 tarps and 14 sheets of plywood. Probably for all that flooding damage at the mansion. All right, very similar problem, different numbers. He's buying plywood and he's buying tarps. The number of plywood sheets was 5 more than 3 times the number of tarps. And this time I know he bought 5 tarps, but what I need to find is plywood. That's what I'm looking for. So if the number of tarps was 5, I can just kind of plop that right into this equation, right? It's 5 more than 3 times this. So 3 times our 5 tarps is 15. And I know it was 5 more than that. So it was 20. The number of plywood sheets he bought was 20 if he bought 5 tarps. A bookcase is on sale for $120, which is 2/3 of the original price. Quite often when you see the word is in a word problem, that's where your equal sign is going in. 2/3 of the original price. What variable do you feel like using? I mean, I'll just use X because I'm lazy. What was the price before the sale? So we want to go back to like, okay, 2/3 of it is 120. What's 3/3 of it? I'm going to show you several strategies. One way to get XL by itself, we can just divide by 2/3. Divide by 2/3, and we get a lovely number. Another way is if $120 is 2/3, then half of that would be 1/3, right? So $60. And if $60 is 1/3, then the whole thing, 3/3 or 1 would be 60 times 3. It'd be 180. No equations necessary. Did it all in my head. Amazing. Of course, listen, you can divide by 2/3. It's fine. Sorry, I left out my x's. Okay. 1x. And then one other way you can solve this, if we have 120 equals 2/3 x is, we can not let that fraction freak us out and just remember that it's 2 times x divided by 3. We could get rid of this divide by 3 by multiplying by 3 on both sides. And then we could get rid of that times 2 by dividing by 2 on both sides. Of course, if you don't mind dividing by 2/3, do it. You'll get 180. The sum of addition of twice a number, twice is going to be times 2. And for our number, I don't know, how about n today? Could be x, doesn't matter. The sum of twice a number and 7 is 15. Okay, so it's addition because we had sum. What's the number? All right, well, let's do it. Twice a number plus 7 gives me 15. Like, if you didn't think about this, you just thought about something plus 7 is 15. Would you know what this something is? I mean, you probably do. It's 8. And now we say, okay, well, that number was 8. But what I want actually is half of it before it was times by 2. So I divide by 2 on both sides, and I've got 4. The sum of twice a number, 4 times 2 is 8. And 7, 8 plus 7, is 15. Yay, it worked. Okay, this is just a practice, and it's a good one to do in your head, out loud to this video, to your cat, whatever. But what we're going to do is read this algebraic equation in a word problem. We're going to make it into a word problem, all right? So there's so many ways to do it. Here's what I'm going to say first. The sum of 2 times a number and 7 is 11. We could also say, though, Lindsay had some numbers, of stickers. She cut them in half, so she had twice as many stickers. And then she got 7 more stickers. Now she has 11. How many did she start with? I'm sure there's other sillier things we could do. Lindsay had X number of dollars, and somebody doubled it. And then she found $7 in her pocket from the laundry. Now she has $11. How much did she start with? All right, you try to do this one in your head quick, or pause so you can take as long as you want. Write yourself a little word problem. Here's mine. Lindsay had 45 Reese's. She ate a bunch of them, and now there are 28 left. How many Reese's did Lindsay eat? We could also say the difference of 45 and a number is 28. There's lots of ways you can do it. But it's helpful to practice going back and forth so that then it's easier to recognize when you're sitting down to a word problem. How about this one? The product of 3 and a number is 15. Thrice a number is 15. Lindsay scored 3 times as many goals as her friend. If Lindsay scored 15, how many did her friend score? You will also see word problems that ask you for more than one number. So here we've got the sum of 2 consecutive numbers is 31. What are the numbers? So we've got something plus something makes 31. And we want to figure out what those numbers are. So whenever you see consecutive, hopefully you remember those special phrases we had at the very beginning here. We're just going to decide what the first number is. And we're just going to pick a letter. Any old letter. It doesn't matter. So I'm going to say it's X because we always use X. My next number that comes consecutively after X is just like X plus 1. It's one number larger. So what I'm saying is X plus an x plus 1, the next number, makes 31. And now I can combine like terms and say I have 2x plus 1 is 31. And now I solve for x, just like I might for any old problem. I end up with a number, and then careful because I'm not done. It wants to know what are the two numbers. Here they are 15 and 16. Is it true that these are consecutive? Yes. Is it true they add up to 31? Yes. Thank goodness. One number is 5 more than another. Number, other number. This number is 5 more. Yes. The sum of the numbers is 21. Find the numbers. So number plus number is 21. So first sentence told me this. Second sentence told me this. I can combine these information, these two pieces of information together and put my x and my x plus 5 here. And then, I'm off to the races in solving. 2x plus 5 is 21. I'm going to subtract from 5 from both sides. I'm going to divide by 2, and I'm going to say x is 8. Careful. That's not what the question doesn't say what's x, right? It says find our two numbers. So we have 8 and another number that is 5 more than 8. Ready? And 13. Are those 5 apart? Yes. Do they add up to 21? Yes. 3 consecutive even integers. Whose sum is negative 24. Yikes. All right, so we have 3 consecutive even integers. Since they are consecutive evens, they go in a row, but they have to skip the odds, right? So if we start with x, the next number is going to be 2 more. And then the next number is going to be 2 more than that, which is 4 more from the original. All right. Now, combining like terms, I've got 1, 2, 3 x's. And I've got 2 plus 4 is 6. 3x plus 6 equals 24. Why are we solving it on the top? Let's do it on the bottom. Oh, well. Minus 6 minus 6. And 3x equals 18. Divide by 3. Oop! Negative 24. Oh, back in time. Dun, dun, dun. You guys, don't drop your negatives like I just did. Negative 24 and negative 6 makes negative 30. Divide by 3 and x is negative 10. Now, careful again. I have to say all 3 of them. So it's negative 10. And what's my next number? It has to be negative 10 plus 2. So we're getting closer to 0. Negative 8. Negative 6. Double check. Do those add up to negative 24? Yes. Phew. Oh, this is a terrible problem. A married couple earns $1,100K a year. So partner 1 plus partner 2 makes $110,000. The older partner earns $16,000 less than twice what their younger partner earns. Okay, side. Let's do that over here. We've got older, younger. The older partner earns $16,000 less. So we have to minus $16,000 twice what the younger one earns. Okay, so if this was older plus younger equals $110,000, I can just put in my Y for younger. But for older, I'm going to put in this mess here so that I only have one variable to deal with. 16,000 less than twice the younger partner. Whew. So I really had 2 equations here, right? I had one equation for the older partner and then one equation for how much it is when we add them together. And now this is the one I'm going to solve. All right. Combining like terms. 2y and another y is 3y's minus 16,000 gives me 110,000. I'm going to add 16,000 to both sides. And then I'm going to have to divide everything in a moment here by 3. And so I'm going to go ahead and divide that all by 3. And I'm going to find that the younger partner makes 42,000. Now, careful, I'm not done. So we decided that the younger partner makes 42,000. I need to now figure out how much the older partner makes. And there's 2 ways to do it. I could take 42,000 and plug it into this equation here. Or I know they add up to 110. So I could just do 110 minus that 42,000. So the older partner makes 68,000. Oh boy, is it true that that is 16 less than 2 times the younger? 2 times the younger would be 84. Subtract 16. Yeah, I think so. And they add up to 110. Fantastic. Let's keep going. Erica earned $50,450 last year between her 2 jobs. Okay, job 1 and job 2 together makes $50,450. All right. Her job at the store, oh boy, let's say this was the store, made $1,250 more than 3 times what she earned at the school. How much did she earn at school? How nice, we only have to answer one. So convenient. Store, school. All right, her job at the store made $1,250 more. I'm going to just call this one X, all right? Then 3 times what she made at school, which was X. How much did she earn at school? So school was X. Oh, that was nice. Smart of me to make how much did she earn at school X, because that's what the question asked for. I was not even paying attention to do that thoughtfully, but I'm so glad I did that on accident. All right, so combining this equation into this equation we made up here, we're going to write this whole bad boy out. 3x plus 1,250 plus another x gets the 50,450 she makes all together. Combine like terms. 4x plus 1,250 equals 50,450. We're going to subtract on both sides. And definitely get a number. Sorry, are you faster than me? Do you already have this done? 4920 4x. And then we're going to divide by 4 on both sides. And that I got that x equals 12,300, which fantastic. This time, that's all they were asking for. If they needed to know this, how much did she make at the store, we could find it too, but it didn't ask. So how nice. We could be done.